Hello everybody and welcome to today's video. In today's video we're going to make a simple C command line application from scratch. First of all, I'm using a terminal here. You can use any other editor you want. I'm going to use Nano for this tutorial like in my other videos. So first of all we create our C file. So let's call it CLI. So CLI.c. I press enter and now I'm GNU Nano 9.1. I can type in and do the stuff I want in here. First of all, we want to print an output to the command line. We start, how every C program starts, with our main loop. We call it main and make some brackets here and return 0 to say that the program runs correctly. Then we save it, in my case Nano with Ctrl X, then Y and then enter. First of all we need to compile it, so we're going to use GCC. Then I give it my file, so I give it CLI.c, then -o and then CLI. I press enter, and if you look here, we now not only have our C file but also some binary file called CLI. So what is GCC? GCC is the compiler I do use for my videos. GCC stands for GNU Compiler Collection, and it does help me to compile my C scripts I did with you to an executable I can run on my system. So it's the good readable C code I do with you that gets compiled into machine code I cannot read. Then we start our program just like this, and it did work. And we see it is the return code 0. If we're going to change the return value here, as example to 100, and then compile it again, and then execute the program with this command, we can see that it is this return value. Yeah, this is definitely a working C program, but we want something a bit more complex for this video. So we need to print a text to our command line. First, you need to know how it's called. It's called the standard output. We cannot just say print like in any other programming language, like Python, but we can say printf, and then we can say that we want to return still 0 because the program runs correctly. Then we can add a text here, like hello world. And if we want to execute this, or at first compile it, we get an error. We get an error that in our function main, there is a declaration of a function called printf that isn't there. So you need something to get this printf. In our case, the compiler is so smart that it gives us a solution to this problem. We can just enter include and then the standard IO header. Let's just do that real quick. So we say include and then we say standard IO.h, like this. Then we save the file and we compile it again. If you run it now, you get a hello world. But you see, it's in the same line as my command line, so we need the symbol for new line. In our case here, it is the symbol with this \n. You need to understand that all of these are ASCII characters, so the H is an ASCII character, the E, the L, the O, and so on. But this is also one ASCII character. Yeah. Good, then we can save it, compile it, and we do not get an error. Then we can start it, and we see hello world with a new line. The \n is, by the way, the same as the enter key on your keyboard. Now we can go on. Instead of using printf, we can declare what we want to give out a bit more directly with fprintf. This program now won't work because we have two arguments in fprintf. The first one is where we want to print something out, and the second one is what we want to print out. In our case, we want to print out in the standard out, so we say standard out, then we do a comma, then we do the second argument hello world. This is going to do the same thing as printf hello world. But what is the standard out? The standard out is the output stream you do have in your terminal. So in my case, it's for this program as example cowsay. It's exactly this. This is the standard output of cowsay when I do give it the argument. But what is the standard output? We also want to give out some error codes. What we could do with fprintf, then standard error, and then a message like, I don't know, something like this. This would definitely work. The standard error is not the same as standard output. It sure does also get output here, but it isn't a normal output. It's for errors. So it's something that goes wrong, an error you want to give the user. That's not what we want to do here. We want to do here just this for now, but we know where we output it. So I'm going to save this file, compile it again, and execute it, and we see hello world is printed out. If I'm going to pipe it into something else, that's something I can do in my command line. As example, I pipe it into my wl-copy. That's because I use Wayland and I can do it like in my clipboard. You don't see it here. If I say wl-paste here again, you see the hello world is there. If I'm going to my nano file and do a printf in my standard error again, in standard error with some text like this is an error message, like this. Maybe we add a new line here and just a semicolon here. Then we save it and compile it. You see, if I execute it like this, we do have both things here and you don't see something else. But if I execute it like this again and paste the standard output into my copy, you see this. There's only the error message and not the real standard output message. If I do wl-paste again, you see here's the message. So yes, this message is not lost. It's just piped into my Wayland copy, but the error message don't get piped by this pipe. Now we can make the program a bit more complicated. First, we're going to add some arguments into our main function that gives us more ways to interact with the program. Let me explain. We don't only say void because we want what here is. So we're going to say int argc like this, and we're going to say char, and then we need a star symbol, argv with those brackets. That's literally everything we want and need in this main function. Obviously like this, sorry. because it declares first an integer, how much arguments we do have, and then the arguments itself, what we can index on. But how does it work with the arguments in our C program? So it is pretty simple. You do have the argv. What it does is an index where the first element, called 0, is this thing here, the second one this thing here, the third one this thing here, and you get it. It goes on. But the argc is the number of elements. So if we only have this, it's 1. If we do have this, it's 2. This, it's 3. This, and you get it. We can start this program like this without any problems. So I can compile it first, gcc, and then I can start it without any problems. And you see we do have a error message, our text, and nothing else. Now we want to parse those arguments and to get them at all. First, we could just print them. So I'm going to cut this out, and I'm going to print some argument here. We could just say argv, then we can say 0. This is going to give us the name of the program. So what happens here? The sh, this is from my shell, and this is what we outputted. So .cli, you see, this is exactly what I did here. I can do something like, for example, I can do CLI 1, 2, 3, and I just get this CLI because this is the zeroth, so the first thing we do have here in our program, because this is the first argument we do have here. If I do here a 1 and I say this, and then I do this and execute this, we get the 1 we have here. You see, this is the 1. If I do it like this, we get nothing because there's no argument. Great. We now need something to parse through this thing. So we need to parse through this thing and index through it and find some arguments. In my example, I'm just going to look at first if something we have here is the same as something we want to search for. So we need a loop because we loop through all the points. How to do it? A loop in C is just with for, then we declare where it loops over. In our case, an integer called I that starts with the value 1, like this, and this loops while I is smaller than argc. Remember, this is the integer we declared here. What is the number of arguments we do have? So while r is smaller than the number of arguments we do have, we run this, and all the time we do say I plus 1, we can say it with I plus plus. So this is just always make I plus 1. Then we close this bracket. So this is our argument for the for loop. And then we say what we technically do. So I'm going in the next line. Do this brackets because this is always executed, what is in here for each time. And we're going to parse here with our if statement. So we say if, and then we need to use this argv character on I, and we need something else we search for. In my example case, we use the -h flag or --help flag. But how we can do that? You just need to know that this here is a pointer to some text. So it's not really the text, but a pointer. When we say dash h, this is also a pointer to this string in somewhere in the memory. This is not comparable. Even if this is the same string, it's not the same. So we need something to look every character through and look if it is the same. For this thing, there is actually a function we can use. This function is called strcmp, and what it does is pretty simple. It does look at two inputs, so first of all this string, and second of all this string, and then it looks how the alphabetically order of those strings is. So it gives out a number if this string here is alphabetically before this one, and it gives out another number if this string here is alphabetically before this string. But it also gives out a 0 if these things are the exact same position in the alphabet, and that must mean that they're the same, so we can use this to declare if the strings are the same. So we can say is the same as 0, because 0 is 0, that's the same point in the address, so this will work. String CMP isn't in standard IO. String CMP isn't in standard IO, but it is in the string header. So we can include the string header here. Include string.h. This header provides us a lot of string utils. We need not all of them, we need like a handful of them, not even, but we need this one here. That's just the simplest way to manage to do that. So now we can look if this is the same. We go through all of this, and this will technically work and is a complete fine program like this. So we can go in the next line, add our brackets like this, and add something is going on here. So as an example, we add here a printf, or as we learned, we can use fprintf to also declare where we want to output something. So we say standard out, and then we can say a text like this is an help message. Then we go through this program, compile it, and execute it. We see nothing. I can do a lot of things here. We see nothing. But if I do it at -h here, we see our first, we always give out the first one, and then we get our text. This is an help message, and then here's the shell. Perfect. This technically is the right program. It does work, it does what we want, everything's fine. I cut this print here out because it's unnecessary, and I do want to do this as a function call. So we do another function. We call this function help function, or anything like that, or print help or something like that. First, we going to do a void print help is a good name. Print help with the input void, so none input, and then we do those brackets and do a lot of printing stuff. We can use printf here. We don't need fprintf because it's just an unnecessary more steps to write down. We can use this in this case. Let's give it a name. Maybe we do. Let's give it a name through a variable. We declare a variable called app name here. Define app name. I don't know. My underscore first underscore CLI. This is a good one. And then we're going to use this here with the %s flag for string, and then a simple CLI. Then we say app_name, and we enter this program. This is our first output we do here. Maybe we do another line here that would look great like this. And then we say printf usage, or just say options. You can do it. You can do a lot more if you want, but that's what I want to do here because I want to keep it simple, like this. And then we can add a lot more options here, but I keep it also simple with -h, and maybe we add --help too, to help menu, to get the help menu. And then that's about it for now. Then we're going to add it here. So I'm going to say print_help, and then we're going to add the --help thing here too. So we have these lines for OR, and then we technically just copy this thing. So I'm going to do exactly this. I'm copying this in here, but I'm going to say --help like this. I save this program. I'm going to compile it, and I see one error here. A semicolon is missing. I'm just looking into this program. Yeah, of course, we do miss here some semicolons. Here the semicolon is there. Do have this too much? Yeah, like this. I guess this will work now. Yeah, it does. And you see, I'm going to cut this out because it's a bit unnecessary. We see my first CLI, a simple CLI, options -h. And if I don't do this, it does nothing. And if I do -help, it does the same. No, it does nothing. Yeah, it does print it multiple times theoretically. But if you want multiple times, you can do it. So yeah, that's fine. Yeah, that is what we want. And yes, we can make this program a lot more complex and add more functions. Something like a versioning, something like a real function for this program. But this isn't really what I want to show you in this tutorial. I'm just wanting to show you how to make a CLI, and we surely did. We learned about the standard IO and the string headers. We learned about how a function works. So we do have this function that does something for us. We learned about how to print into different streams. We learned about a program giving us a return value, so something like 0 or 1 if it's an error. We learned about the for loop and the if statement. We learned about the main function in C, and that does have arguments we do have here. We learned about the indexing of those. We learned about string CMP and about the alphabetically lookup, and then that it gives us 0 if it's the same. We learned about the pointers, and we learned about our OR, and a few more things I missed out, sure, but that's about it. So we learned a lot of things here in this tutorial. It is just a simple tutorial for beginners, but it also is a C program you can compile and you can work with. You can add more functions, like as example some API calls you want to add in a CLI, and a lot more. This just shows what you can do. Thanks for watching my video. Have a great day, a great whatever you do have right now. Bye bye.